Now we're in section 11.3. Prior to this, we talked about permutations where order is important. So we said that the construction was a factorial. In other words, we could have the series of numbers like 5 factorial, and we would get 120 because it's 5 times 4 times 3 times 2 times 1, a factorial. Now, if we had a subset, it was easier to 5p and however many the size. In this case, we use the calculator. And I'm going to show you that. So I would enter the 5, I'd hit the math key, I'd go to PROB, and I would choose number 2 and enter 4. And we would get 120. Ooh, well, let me look at 5 factorial. Maybe I did bad math there. Sorry. It is 120. So those happen to be both the same. That's unusual. But we're talking about how many in order elements in a set are important. Order is important. Well, now we're going to talk about combinations. So in combinations, we talk about subsets on a screen, and these are groupings. The order is not important because we have groupings when there is no hierarchy of the listing. And we have them in the size R. Now remember, a subset can be an equal set, but not all subsets are equal sets. All right, so in this case, we're saying we want the count of size R in set N. Because we say now NCR, NCR. Because we don't want to enter all of this in the calculator because that's the manual entry for combinations. All right, so we're going to look first at the capital C meaning combinations, and we're going to see the difference in what we have. So here we have all unique letters, and we have an N equals 4. It's all the letters of math, M-A-T-H. And here is the same thing where N is 4. And on this one, we want 4P3. And on this one, we want 4, sorry, that's a C because it's a combination, C3. So let's look at our calculator. I'm going to place it over here. And we're going to enter the 4 math key, PROB, and we're going to do permutation 2 and enter 3 and enter. We have 24 unique ordered elements of size 3 from a set of 4. Now we're going to do the combination, 4 math, PROB, and we're going to do number 3 and choose 3. And we're going to get 4. Notice that this is usually larger than this uh, because in doing subsets of a set in combinations, we don't have to worry about A, B, C, so on and so on. All we have to worry about is that the letters are unique within that grouping. So we're going to learn the calculator first. And we've already talked about it. We first construct uh, AR. Second, on home screen of the calculator, enter N. You're going to go the math key. And we're going to arrow over to PROB. Sometimes it can be PRO, like pro. And then we're going to choose number 3, NCR. And the next step is enter R value. And we'll have them how many groupings of size R we have in the set of values. So we're going to do some now. Now remember, you can always pause the video to make appropriate notes. So let me get the calculator up, clear it. So I'm going to enter the 9. I'm going to go to the math key, PROB. I'm going to do number 3, and we're choosing a set of 8. And I get 9 groupings, size 8 elements. Order not important. Now here we have an interesting one, 6C3. So it's a combination. We're going to enter the 6, hit the math key, go to PROB, and hit number 3, and hit 3, and enter. And we get 20. Because we have, even though we had a larger set of elements in the first one, we had a larger size of groupings. We had a fewer amount of groupings possible. Here we have a smaller set of elements, but our set is also small. We can make 20 groupings. Now this one's interesting. What do you think the answer is? Well, if we have 15 elements and we want a combination of 15, well, that means I'm going to get a 1. But we want to see what the calculator says because some of you are driven by using the calculator, and we have to prove it. We come from Missouri. So there it is, 1. Now we have this complicated item. You have options here of you doing them individually or uniquely. So I'm going to do this part right here and then subtract that because they're pretty large numbers. So let's see if I can do it. I don't know. We have a permutation and a combination. So I'm going to have 20 math, PROB, and I'm going to do number 2 for NPR. And I have a size of 15. And now I'm going to go up arrow there so it's in the same thing. Divided by 15 math, PROB, factorial, which is 4. And we enter. And I get 15,504. Of course, you can enter it all at one time and it'll be okay. but I'm doing it in pieces just so that you can see it's doable in any method you'd like. So I'm going to choose number 3 and enter 15. And I get, and what this one shows is a fact that because we divided by the 15 factorial, uh, we're taking out all the duplications. And so we end up with 0. Pretty fascinating, right? All right. So let's see what else we can get into. Now we're going to application problems. So we're reading or content. We're looking for buzzwords like groupings, committee, um, all of those items that we are looking for. All right. An election ballot asks voters to select 5 city commissioners. And this means order not important. Commissioners are not the chair, the holder of the position. It's a grouping. So now that we know, we're going to use combinations. All right. Of a group of 18 candidates, in how many ways can this be done? So we're talking my R is 5 city commissioners, and we have a set of 18 eligible. So we're going to write 18 combinations of size 5. And now we're going to use our calculator. 18 math, PROB, number 3, and we're talking size 5. And we have 8,568 ways of getting a group of 5 commissioners. All righty then. Okay, now this one is kind of outdated. I know most of us have audiobooks on our phone or even Kindle on our phones or the apparatus, iPads, and so forth. So, but this is important in reading for language. Of 11 possible books, so my total quantity is 11. You plan to take 3, or the size of the group that you're taking is 3, and on vacation. So this means that it is a group of 3. Therefore, it is a combination. All right. So we have 11, choose 3, because we want to know how many ways can we take 3 out of the 11 on our vacation. So I'll enter the 11 first, math, PROB, number 3, and I'm putting a 3. 165 ways. 3 books out of the 11. All right. Now this guy right here, and let me move this forward. There you go. And I don't have to be constantly giving you a headache. To win at Lotto, In one state, one must select 7 numbers from a collection of 50 numbers, 1 through 50. The order in which the selection is made does not matter. So we're talking combination. How many different selections are possible? So our N, 50, and 7 numbers from that collection. So the size of our grouping is 7. Choose 7. So we're going to enter our 50 first, go to math, move to PROB, go to number 3, and enter 7. It's going to be a big number. Yes. 00. Right. 99,884,400 ways to do that. All right. So that's how many grouping of size 7 we can get from a pool of 50 numbers. In how many ways, now here's a dual, in how many ways can a committee of 4 Dems and 3 reps, Republicans, be formed from a group of 8 and 9 Republicans? All right. So here we have the inclusion of 2 events, and they're independent. Okay. One of them is asking for 4 Democrats and 3 Republicans. And there are groups. See where it says here, committee. Committee meaning groups. So here on the Democrats, we have 8, choose 4, and to that we're going to do Republicans, there were 9, choose 3. In statistics and in counting principles, and means to multiply this and that, because we're then using the fundamental counting principle. And the counting principle tells us that if I have a set, one set, and I want to know, and I have 2 independent sets, and I want to know how many combinations we can make, well, we're going to multiply. That's at m times n. So what I'm going to have is 8, choose 4, times 9, choose 3. We can't, we use everything in our arsenal. So I'm going to enter the 8. I'm going to go to math, go to probability, choose 3, and enter 4. And then I got to go side arrow to make sure the cursor is in the middle, times, and then I'm going to do the next one, 9, math, PROB, 3, and I'm going to choose 3. So I've checked, oh dear, what did I do there? I had a, sorry. Oops. Let me clear that and I'll try it again. I was sideways. I am so sorry. Math, PROB. I'm going to choose 3 and do 4. And I go side arrow, times, and then I'm going to enter 9, math, and I look at what I'm doing. I'm sorry. A PROB, and then I'm going to go with the number 3 and enter 3. Now it looks good. All right, so I'm going to have 5,880. All right. So here we have another example. We're going to look at that. A person has 4 dress shirts, 3 ties, 3 jackets. In how many ways can the person select a dress shirt, a tie, and a jacket for work today? Now, this is a review problem, isn't it? Because we don't have one set we're working with. If I have more than one set, I have to use fundamental counting principle. All right, so I have 4 dresses and 3 ties and 3 jackets. So that is 36 ways to select an outfit. All right. Well, we've learned how to apply combination counting principle and execute. And we know that the entry or the construction would be N, count of how many elements in that one set, choose, and then R, and R being the size of the grouping. Thank you so much for listening. Very easy section. I will do the homework promptly. Thank you for listening.